Hello everyone, I am Gautam. Today we are going to discuss a topic about digital oscilloscope. So let us see first what is an oscilloscope is. So an oscilloscope is an instrument which is an electronic instrument which displays the changes in the voltages graphically. So it is known as an oscilloscope. So it is utilized to process, capture, display, analyze and store the waveform and bandwidth of the signals. So there are two types of an oscilloscope we are currently using. So they are the analog oscilloscope and the digital oscilloscope. So they are classified based on their types of signals. So we are going to see the topic about an digital oscilloscope. So the both are same, but their output varies on the analog system and the digital system. So this is the picture of a digital oscilloscope. So you can see the voltage variations. So let us see the block diagram of the digital oscilloscope, and the parts containing in it are amplifier, digitalizer, memory, analyzer circuitry, waveform reconstruction, CRT, which is a cathode ray tube, horizontal amplifier, time base, triggerer, clock, horizontal plates and vertical plates. So let us see the functions of these each blocks. So first we are going to see about the amplifier. So an amplifier which is used to check that the incoming electrical signals is in the right size or not. So if the signal is too weak, which means there is a low voltage, so the amplifier boosts up the voltage so the oscilloscope can see it properly. If the signal is too high, which means the voltage incoming voltage is very high, the amplifier can reduce it to prevent distortion so that the signal fits nicely on the screen. This amplifier helps the oscilloscope show the waveform of the signal, whether it is a small signal or a large signal, making sure that it's visible and easy to analyze it. So its main job is to adjust the signal to a level that the oscilloscope can work it and display. As we can see here, so this is the size of the signals. So the amplifier determines the sizes. Next, we are going to see about the digitalizer. As the name itself it contains, it is used to digitalize the things. So, the digitalizer converts the analog signal, the real world electrical signal, into a digital format that the oscilloscope can process and display. As I said before, it is first converted into a analog to digital. So ADC, analog to digital converter, contains in the digital oscilloscope. So next is the memory. So the data which we are getting the signals, so these are stored in these memories and then it is displayed on the screen and analyze it over time. So the oscilloscope memory stores the data points produced by the digitalizer. So wherever the digitalized inputs are, then it is stored in the memory. This can include thousands or billions of data points depending on the oscilloscope's resolutions and settings. The oscilloscope can then access this memory quickly to show the waveform on the screen. So whenever it is required, we can retrieve it. So next we are going to see about analyzer circuitry. So the part of the oscilloscope which captures, digitalizes and processes the input signal using components like amplifiers, ADCs and filters, allowing the signal to be analyzed and displayed. So first it is captured, digitalized and then it is a process in this analyzer circuitry. Then waveform reconstruction, the process of creating and displaying the signal's waveform by sampling the signal, storing data and reconstructing it on the screen for visual representation. Triggerer, so triggerer is used to start something. So in the same way, the triggerer in the digital scope stabilizes the waveform. So it is used to stabilize in a correct form. as we can see here, it is stabilized in a correct form of each lens. So these are done by the um, waveform reconstructions and triggerer. So it is activated based on the specific conditions such as voltage level or edge transition. So this synchronization prevents the waveform from drifting and ensures a stable, repeatable display of the signal. Next, we are going to see about the clock. So the clock which we are used in the digital oscilloscope, it governs the timing of the signal sampling processes. So it checks and it provides a consistent timing reference that controls of the frequency at the oscilloscope's ADC, which is analog to digital converter input signal. And then time base. The time base in the digital oscilloscope controls the horizontal scale of the waveform, determining how much time is represented per division on the screen. Next, the horizontal amplifier. So as the same work that done by the amplifier, the same is also done by the horizontal amplifier. So it adjusts the width scaling of the signal based on the horizontal axis, not on the vertical axis. It amplifies the signals in the horizontal direction, affecting how much of the signal is displayed across the screen. Next, the all we know is cathode ray tube. So it is also used in the old display technology in the traditional oscilloscope. It consists of a vacuum tube with an electron gun. So the electron gun emits a beam of electrons. The electron beam is then directed toward a phosphorescent screen where it lights up to a form of visible waveforms. The CRT was once the primary display method in oscilloscopes, providing real-time waveform visualization by deflecting the electron beam based on the input signal's voltage. The horizontal and vertical deflections corresponding to the time and signal amplitude respectively. Most modern oscilloscopes now use LCD or LED screens instead of CRTs. So currently in the digital oscilloscopes, they are not using of CRTs, they are using LCD screens or LED screens. Next, we are going to see about the operating principle. So based on which this DSO, which means the digital storage oscilloscope or digital oscilloscope, is working. So first, an analog signal, conditioning it for proper measurement and converting it into digital form using the digitalizers. The digital is stored in the memory and processed for analysis. The processed data is then reconstructed and to display the waveform on a digital screen. So first we get a signal, then we are converting into digitalizations, then we are analyzing the signals and then reconstructing it and displaying it in a digital form. So we are getting in an analog form and we are displaying it in a digital form with the time and amplitude axes. So in this, triggering is used to stabilize the signal, which ensures a consistent and stable waveform for measurements and analysis.
Advantages of digital oscilloscope. Automated measurements offer built-in features for automated calculations including voltage, frequency, rise time and signal abilities. Multi-channel support can analyze multi-signal simulations, which is ideal for debugging multi-signal systems. Real-time digital signal processing (DSP) allows advanced features like fast time transfers (FFT), filtering and mathematical analysis. Ensure display features: high resolution LCD or touchscreen displays provide detailed color code waveform and iterative interfaces. Data logging can continuously monitor signals and record long-term data for turns and endments. Disadvantages of digital oscilloscope: high cost, more expensive than analog oscilloscopes, sampling errors, resolution limits, dynamic range, EMI sensitive, data loss, software dependency. Comparison of analog instruments versus analog instruments and dynamic digital instruments. Signal representation, accuracy, response time, error, ease of use, data storage, noise amplitude, advanced features, resolutions. Cost. Applications of digital oscilloscopes: electronics and circuit designs, communication systems, research and development, signal generation and verification, medical electronics and consumer electronics.